So we've done all this stuff with the head table and the loca table, but now we are ready to look into the glyph table, which is where all the good stuff is. And hopefully we can actually make a canvas on this web page, which is currently still blank and not showing anything. But yeah, hopefully we can make a canvas on this web page and maybe draw some of these shapes that that supposedly are somewhere encoded into this file of bytes. Um, so yeah, let's move on, carry on with our parsing. So we just got our locations, and yeah, to clarify what this means is locations location 0 is where we'll have to look into the glyph table, or the offset into the glyph table, to find glyph number 0. And then this is where we'll find glyph number 1, and this is where we'll find glyph number 17. Although this is an offset, so we need to actually add it to the glyph table main offset. So yeah, let's get the glyph table directory entry, and then we can get its offset. Okay, so this, for example, would be where to find glyph number 17. So yeah, we can get this loop again. Or actually, you know what? Maybe we can just do it inside this loop. Why not? We don't actually need the locations array if we just use the locations immediately. Okay, so we're just iterating through all the glyphs. Okay, so for each glyph we get where do we find it in the glyph table. That is LOC. So then the actual, what do we want to call it? I guess glyph offset. That's going to be the table offset plus loc. Okay, so oh wait, I've messed up the formatting of all of this. Okay, and oh, we're no longer returning locations, so let's get rid of that for now. Okay, so what are we going to find for each glyph? Let's take a look at what the documentation says for the glyph table. Okay, so it says the first thing we'll find is a number of contours. So what this means, I guess, is I don't know, let me see if I can. Oh yeah, we have this font opened up here, right? Oh wait, let's open up the actual font that we're using. Open containing folder. Wait. Oh, here, yeah. Okay, so there's all this there's all these glyphs in this font file, right? So some of them are pretty simple, like this L. Like this L is just a rectangle. So, and presumably it's just going to be 4 points. This K is a little more complicated. It's going to have even more points. But yeah, there will be like this corner and then this corner and then all of these corners. The coordinates of those will be in the font file. Also, it looks like there's something interesting happening there. It's very subtle. Anyways, some characters like this I are different because there's actually like two parts to it. There's like the rectangle part at the bottom, and then there's the circle part at the top. So these will be represented in the font file as separate contours. So whatever glyph corresponds to the letter I, it's probably going to have number of contours of 2. One for this rectangle and one for this circle at the top. But also letters like this D, they're also going to have 2 contours. There's going to be one for this outside, and there's also going to be one for this inner, the inner circle, like the hole inside the D. Because you need to like specify what both the outside and the inside look like if you have a shape with an outside and an inside. So similarly, A is going to have 2 contours for that reason. What were there any like other interesting things that I could mention? Oh yeah, let's look at this capital B. So this capital B actually has 2 holes. So this B is going to have 3 contours, one for the outside and two more insides, like because there's 2 inside parts. Yeah, similarly for the number 8, that's also going to have 3 contours. Anyways, so that's basically what is meant by contours. It's like there's just going to be different parts of the outline that need to be separately described. So yeah, let's get the number of contours for each glyph. And that, well, that's just an int 16. Oh, that's okay. There's something more interesting about this. Okay, if the number of contours is positive or 0, it is a single glyph. If it's less than 0, it's a compound. Okay, so I'm not going to deal with compound glyphs. I'm pretty sure that this specific font doesn't have any compound glyphs. But yeah, I mean, we can actually just check that. So let's like try to get the number of contours of this glyph. So that's going to be view.get int 16 at glyph offset. I could say +0, but there's no need. Okay, so it does look like there are some negative ones in here. But maybe among like the first 20 or so glyphs. Yeah, among the first 20 glyphs, there's no compound glyphs. So yeah, I'm just going to ignore the whole thing about compound glyphs. That's just the whole thing. Okay, so next we also have a bounding box. So we have like an x minimum, x maximum, y minimum, y maximum. Okay, so we are starting to get into some interesting coordinate stuff. So we might start like creating a canvas on the web page so that we can actually understand these numbers. Okay, so this is what we were going to find at the beginning of the glyph. And the next part, it says it depends on whether it's simple or compound, but we're just assuming it's simple. So we'll just assume that this directly follows the glyph description. So for a simple glyph, okay, so what is this? This is endPtsOfContours. Actually, first let me parse out the x-min, y-min, and all of that. Then I'll talk about that. Okay, so const x-min equals, these are all, oh wait, actually, what is the data type of these? Oh yeah, I should talk about that. The f word Okay, so what is this? This is a 16-bit signed integer, and it describes a quantity in F units. So I guess F units is like, it's like a geometric unit, like it's used to describe like how far apart things are, like within the glyph. It's not pixels or anything, because like theoretically you could render a font at any size. Like you could render this font at 16 pixels, you could render it at 32 pixels, you could render it at 8 pixels. So like inside the font file, it's just going to be it's going to be specified in terms of like some units, but the rasterizer is expected to scale it to whatever size that it wants. So yeah, that's one thing that we will need in the future. Like we will need to input the font size, and then we need to scale whatever information we find in the glyph table from F units into pixels. Anyways, bottom line is this is a 16-bit signed integer. So yeah, each of these is 2 bytes, and we can get glyph offset plus 2, 4, 6, 8. And then these are xmin, ymin, xmax, ymax. Oops. Okay, so we have that. Maybe we can log those for each glyph. Or let's put them in the order that they're given. Okay, so do these look reasonable? Yeah, I'm kind of just looking to see if like the minimums are less than the maximums. Yeah, we got -14. Yeah, -14. That is a valid thing that can happen in a font, and there are reasons for that, and I won't get into it. Okay, yeah, these look to be reasonable values. Cool. Oh yeah, and we're also getting like the number of contours. Oh, this glyph over here has 5 contours. I wonder which one it is. We'll find out soon enough. Okay, so we got the xmin and ymin, xmax, ymax. So, oh yeah, let me talk about the endpoints of contours now. So this will be the next thing that we find for the glyph. So I mentioned that each contour has to be given separately. So the thing is that in this file, the coordinates are just going to be given one after the other. And yeah, that's also like a whole thing, but we still need to know, like, we have like a big list of points, like the points being XY coordinates. But how do we know which ones belong to which contours? So what this is for is basically to kind of chop up the list into exactly what we need. Like chop up the list so that like in this segment of the list, it's going to be like the first contour, and then this segment of the list, it's going to be another contour. So yeah, this array has pretty much that information. Like the indexes into the list where it gets chopped. It also has like a dual purpose of also telling us how many points there are in like how many total points there are. In addition to, I guess you could also derive the number of points in each contour. Well, okay, let me just like parse this information out of the font file. Well, we already know how many contours there are, so that one is straightforward. So we need to just get that many int 16s. So let's get endpoints of contours. That'll be an empty list. Then we'll say for oh yeah, the index, we'll call this like the contour index, and we're going through each contour. Okay. And then we can get okay, I guess it's going to start at glyph offset plus 10. Wait, is that right? Let me double check. So this is 0, like all of these are 16 bits. So 0, 2, 4, 6, 8, and then 10. Okay, so yeah, that array starts at 10. But then it's also going to be plus, wait, how many bits is each one? That's also 16 bits. Okay, so 2 bytes times the contour index. So let me do this on a separate line. So const we'll get this int 16 over here. Okay, and then we should be able to print the endpoints of contours. And once we have that, it'll be easier for me to explain. Okay, there's a lot of like stray numbers here. Let me just try to find, or let's just get rid of some of these. Like we don't need this. We don't need this. Okay, what is, okay, so now we're just printing the num contours. Let's get rid of this too. Okay, so we have the number of contours. Output num contours. Like this, okay. And then we're listing the endpoints of contours. Okay, so let's look at this one, which is the most interesting. Okay, so we have num contours as 5, and we have these 5 elements in our endpoints of contours array. So what this is telling us is there are 51 points in this glyph. So the last element that we find in our number of contours will tell us the total number of points in the glyph. But it also tells us that points 0 through 10 are in the first contour, 11 through 22 are in the second contour, and then 23 through 26 are in the next contour, 27 through 38 are in the next contour, and then the remaining points, 39 through 50, are in the last contour. So yeah, that's basically how to interpret this. And each contour is a loop, so like within each contour, the last point also connects to the first point. So they're kind of connected consecutively, like point 1, point 2, point 3, point 4. But then like the last point in each contour is connected to the first point in each contour. So there's like there's an 11-point loop of points And then there's, what is this, 23 minus 11 is 12. There's another 12-point loop, and then another 4-point loop. So there's like all these separate loops. Oh, I guess another thing that I forgot to mention is whether the points are listed in clockwise or counterclockwise order determines whether it's a whether it's a contour that borders the outside of the shape or it's on the inside of the shape. And I kind of forgot which one is which. It's probably not important. We'll figure it out later. And but it is important to note that they're going to be in different orientations depending on whether they're the inside or the outside. And we'll see in the future that that actually makes it so that it's easier to write the renderer. Okay, so we got our endpoints of contours. Okay, there's all this stuff about the instructions. I'm just going to skip over the instructions. That's kind of a more advanced rendering thing called hinting. But we're not going to deal with that, and we don't need to deal with that. So all we need to do with this is just skip over it. So we get the instruction length. Let's do that. Oh, we need to keep track of where we are. Let me actually create a mutable variable. So yeah, instead of glyph offset, I'm actually just going to use offset. And I'm going to keep incrementing this as we go on. Okay, so yeah, this also gets rid of our need to always be tracking like how far we are from the start, because we can just add to the offset and then we don't have to worry about everything that happened before it every time we add to the offset. Okay, so first we start the offset at the beginning of the glyph table, and then we get these 5 items, and then we move the offset up to here, pointing to endpoints of contours. Okay, so then after that, we can then add the number of contours times 2. So that should bring us to after this endpoints of contours array. Oh, I think my my previous explanation was wrong, actually, because I didn't read this carefully. It's the array of last points, which means, like, I think I said before. Oh, hold on. Let's make this working again. I think I said before that this means that there are 51 entries or 51 points in the contour, but actually there are 52, and 51 is just the index of the last one. So if I were to redo my explanation, it would be, yeah, so 0 through 11 are in one contour, and then 12 through 23 are in another contour. 24 through 27 are in another, and so on until 40 through 51. And the total number of points is 52, which means that actually I need to fix something in my code. Or actually, no, I don't, because I didn't even do that part yet. Okay, well, I can do it right now. I can say number of points equals the last item in endPtsOfContours. So we'll just get length minus 1. But then we add 1 to this because of what I said. Like if it's 51 that we find at the end of the array, then that actually means there's 52 points because 51 is the index of the last point. Okay, so we got the number of points. I'm going to console log that also. Yeah, so 51 is the last entry, then there's 52 points. 60 is the last entry, there's 61 points. Okay, nice. So where was I? I was dealing with this offset variable, trying to get it to be where I needed it to be. Okay, so the instruction length. Okay, now that is where my offset variable now is. So offset view dot get int 16. Was that int 16 or no? It was uint 16. At offset. Cool. And then we can move the offset past the instruction length. Oh, but then we can also move it past the instructions themselves because the instructions take up 1 byte times, I guess it's just the instruction length. So we'll also add the instruction length itself. So yeah, we're adding 2 bytes to skip over the instruction length, and then we're skipping that many bytes, whatever number we found, instruction length, to skip over the actual instructions. Okay, so we're still in the middle of parsing the glyph table, and the next thing to do is to parse the coordinates. And that is, the thing that we've been after this whole time. It shows us the shape of each character, like the shape of each glyph. So it'll be the most interesting part, but it will also be the most involved part because there's a lot of tricky considerations. So get ready for that next video.